look at us from a distance, might be a smarter kid on our cosmic block, some civilization that is more advanced than we are.
3I Atlas doesn't act like a rock, but it doesn't quite behave like a comet either. Pre-recovery images reveal it was active long before discovery.
Some of the biggest mysteries in the universe are all about other questions, like the question facing skywatchers. What is it?
Its orbit looks suspiciously precise, and scientists are split. Some say comet, while Avi Loeb suspects a probe. In this video, we'll discover whether 3I Atlas is just a comet or something alien. Probe or just a comet? When astronomers first spotted 3I Atlas in mid-2025, they knew right away this wasn't your average space rock. It's only the third object we've ever caught coming from outside our solar system, following the famous Oumuamua in 2017 and Comet Borisov in 2019. But while those stirred up excitement, Atlas brought something else: controversy. From the start, telescopes showed Atlas was already awake, glowing way out past Jupiter, where comets should still be asleep. Normally, comets don't start showing activity until they get much closer to the sun. That early brightening hinted that something unusual was going on, almost like this object couldn't wait to announce itself. But here's where things get even wilder. Harvard scientist Avi Loeb, the same guy who once suggested that Oumuamua might have been a piece of alien technology, jumped in again. He argued that Atlas's path through the solar system was just too strange to be random. It wasn't only coming in on a backwards path compared to the planets, it was also skimming unusually close to Venus, Mars, and Jupiter. By his math, the odds of that happening by pure chance were tiny, like 1 in tens of thousands. So Loeb asked the question no one else wanted to ask out loud. What if this isn't just a comet? What if it's a probe, an artificial visitor, disguised to look like one? Meanwhile, for other scientists, Atlas looks exactly like a comet should. It's growing a fuzzy halo of dust, forming a tail, and giving off gas as the sun's heat hits it. Nothing about that screams alien machine. In fact, the very things Loeb points to as odd, like its early activity, could just be the result of frozen gases that light up quicker than water ice. Perfectly natural, and that's the standoff. Is Atlas just another comet or something much more intentional? One side says the clues point to ordinary space ice. The other says those same details could hide something extraordinary. But the strangest part wasn't what astronomers saw in 2025. It was what they found hidden in older images, active out in the cold. Here's where the story gets even stranger. By the time NASA officially logged 3I Atlas in July 2025, it wasn't exactly new. Hidden inside older telescope images, scientists found the comet had already been caught on camera months earlier. They just hadn't realized what it was at the time. This kind of hidden history is called pre-recovery, and it can completely change how we understand an object. So, what did those old images show? Atlas wasn't sitting quietly out there in the dark. It was already glowing and active, even when it was about 6 times farther from the sun than Earth is. To give some perspective, that's out near Jupiter's orbit, a region so cold that regular water ice should be frozen solid. Normally, comets only wake up when they're much closer to the sun, when heat starts turning that ice directly into gas. But Atlas didn't wait. It was already throwing off material, and that raised some questions. The best explanation? It wasn't water driving the show, it was more exotic ices, like carbon dioxide or carbon monoxide, which can sublimate at much lower temperatures. In plain terms, Atlas was burning fuel that most comets keep locked away until much later in the journey. This early activity created a coma, a thin, misty cloud surrounding its core. Later images from Hubble even showed that the cloud was growing in size, along with the start of a faint tail. By September, the brightness of the whole thing was climbing faster than expected, almost like Atlas was pulsing with energy. Some astronomers even called it outbursts, mini explosions of gas and dust erupting off its surface. Now, to most scientists, this is exciting, but it still fits into the comet category. It just means Atlas is carrying a different recipe of frozen stuff, shaped by whatever alien star system it came from. But if you're Avi Loeb, the guy raising the alien probe flag, Pre-recovery tells a different story. He argues that this early wake-up could be more than nature. It could be evidence of a machine switching on, long before anyone down here even noticed. So which is it? Exotic frozen gases doing their thing, or a hidden engine powering up on the outskirts of the solar system? That's the puzzle the pre-recovery data leaves us with. A comet acting like no comet we've ever tracked before. path too precise to ignore. If there's one thing about 3I Atlas that makes even the calmest scientist raise questions, it's the path it takes through our solar system. Most comets we see cruise in on long, stretched-out orbits that loop them around the sun and fling them back out. But Atlas isn't looping at all. It's on a one-way ticket. Its orbit is so steep and so fast that once it passes through, it'll never return. That alone tells us it came from deep interstellar space. But here's the twist. Atlas isn't moving with the flow of the planets. It's coming in on a retrograde path, basically going the wrong way compared to everything else. Imagine all the cars on a highway moving east, and suddenly one massive truck barrels west, cutting across the lanes. That's Atlas. Even stranger, its orbit slices through the exact plane where all the planets travel. That means instead of zipping through at some random angle, it's actually threading the needle, weaving right into the neighborhood where Earth, Venus, Mars, and Jupiter all circle the sun. And it's not just passing by, it's skimming close. Atlas's strange path isn't just about angles, it comes with a calendar of cosmic milestones. The first big moment arrives on October 3rd, 2025, when the object sweeps past Mars at a distance of about 18 million miles. That's close enough for orbiting spacecraft to get an excellent view, turning Mars into a kind of outpost for studying this visitor in real time. Just a few weeks later, in late October, Atlas will vanish from Earth's sight as it slips behind the sun. From our perspective, it'll be completely hidden in the solar glare, unreachable to ground-based telescopes. For astronomers, that's a frustrating blind spot. For anyone who leans toward conspiracy theories, it's the perfect moment to imagine Atlas pulling off some kind of maneuver, unseen. When it re-emerges in December 2025, it will pass within about 170 million miles of Earth. That's far too distant to pose any threat, but it's near enough for instruments like the James Webb Space Telescope to rake through its glowing cloud of gas and dust, gathering chemical fingerprints and watching how its activity evolves. The final act of this cosmic flyby plays out in March 2026, when Atlas makes a close approach to Jupiter. The giant planet will become the next great vantage point, with both professional observatories and spacecraft keeping watch as this interstellar visitor streaks past. Now, to Avi Loeb and his team, this is where the alien probe idea gets juice. By their calculations, the odds of a random interstellar comet just happening to line up this neatly with 3 major planets are tiny, something like 1 in 20,000. That's the kind of precision you'd expect if somebody aimed it. Most other scientists say, nope, it's just luck. After all, the universe is vast, and weird coincidences do happen, but if you lean toward Loeb's view, this trajectory doesn't feel like a roll of the dice. The size and mass mystery. If there's one detail about 3I Atlas that keeps changing, it's how big it really is. When it was first spotted, rough estimates suggested Atlas might be a couple of miles across, already enormous compared to other interstellar visitors we've seen. For context, Oumuamua, the first object from outside our solar system, was only about 1/4 of a mile long. Borisov, the second one, stretched less than a mile. Atlas, even at the low end of estimates, was massive by comparison. Some early Hubble images hinted at a body anywhere from about half a mile to over 3 miles wide. But here's the catch. Measuring the size of something like this is tricky. It's not like looking at a solid rock. What telescopes mostly see is the glow of the coma, the cloud of gas and dust around the object. That can make the solid nucleus look much bigger than it is, or sometimes even hide its true shape completely. This is where Avi Loeb and his team weigh in again. They argue that the way Atlas moves, or more importantly, how it doesn't move, suggests it might be far larger than most astronomers first thought. Normally, when a comet gets close to the sun and starts venting gas, it experiences a kind of gentle push, like steam escaping from a boiling kettle. Scientists call this non-gravitational acceleration, and it can give clues about the size of the comet hiding inside the coma. With Atlas, Loeb's team claims that push is barely there. If there's so little shove coming from its gas jets, then the nucleus, the solid heart, must be far more massive to stay on course. By their math, Atlas could weigh more than 33 billion tons, with a nucleus possibly over 3 miles wide. That would make it the biggest interstellar object humanity has ever seen. Most other astronomers aren't convinced. They say the lack of measurable push could just be because we're still catching it early, before its gas jets really kick in. Give it more time, they argue, and those little nudges will show up in the data. For now, they stick with the more modest size estimates based on direct brightness. But here's the thing. Whether it's 2 miles wide or more than 3, Atlas is still a monster compared to what we've seen before. And the bigger it is, the more room there is for speculation. Is it just a giant frozen relic from another star system? Or could its bulk be hiding something more? The chemistry drop. One of the most striking discoveries about 3I Atlas came not from its path, but from the strange blend of gases and dust pouring out of it. When the James Webb Space Telescope locked onto the comet, it revealed something extraordinary. Atlas is unusually rich in carbon dioxide. For every trace of water detected, there were nearly 8 times as much CO2. That's the reverse of what astronomers usually see. In most comets, water dominates and CO2 is the supporting player. Here, the roles are flipped. This imbalance explains why Atlas looked active so far from the sun. Carbon dioxide vaporizes at much colder temperatures than water ice, meaning the comet could start glowing and venting gas while it was still out near Jupiter. In other words, it wasn't breaking the rules. It was just running on a different kind of fuel. But carbon dioxide wasn't the only surprise. Observations from the Very Large Telescope in Chile spotted traces of nickel vapor in Atlas's coma. That's an element usually buried deep inside planets or forged in the hearts of stars, not something you expect floating off the surface of a comet. Its presence raised new questions about how and where Atlas originally formed. To most astronomers, this odd chemistry makes Atlas a priceless natural relic. It's a frozen sample from a planetary nursery in another star system, carrying chemical fingerprints from a time long before Earth existed. Studying it is like opening a time capsule from billions of years ago. For Avi Loeb and others pushing the alien probe idea, the story plays differently. They argue that such unusual chemistry could serve as a perfect disguise. After all, what better way to hide advanced technology than inside a shroud of gases and dust that mimic an ordinary comet? Whatever the explanation, one thing is clear. Atlas doesn't follow the standard playbook. Its chemistry isn't just unusual, it's forcing scientists to rethink what an ordinary comet should look like when it comes from outside the solar system, the comet we recognize. As strange as 3I Atlas may be, there's one thing it definitely has in common with ordinary comets: the way it looks. From the very first high-resolution images, Atlas started showing off the classic signs of cometary behavior: a glowing cloud around its core, narrow gas jets, and the beginnings of a long tail. Hubble's early snapshots in July 2025 revealed a sharp, teardrop-shaped halo of dust around the object. This fuzzy envelope, called a coma, is what happens when sunlight heats the comet's frozen surface, turning ice straight into gas and carrying bits of dust along with it. That material reflects sunlight, creating the ghostly glow that makes comets so dramatic in the night sky. As weeks passed, the coma didn't just stay, it grew. Later, images showed it swelling in size as more and more material boiled away. And trailing behind Atlas, astronomers began to notice a faint streak, the start of its tail. By late summer, that tail had stretched into a distinct line of dust and gas, pushed away from the sun by solar radiation. It wasn't a perfect stream. At times, it looked uneven, almost like it was being sculpted by small bursts or outbursts, but it was undeniably there. This is the sort of evidence most scientists point to when they argue that Atlas is acting like a comet, not a machine. It's venting gas, it's building a tail, and it's glowing brighter as it approaches the sun. These aren't things you expect from alien technology. They're what you expect from a giant chunk of ice and rock being cooked by starlight. But even here, the story isn't simple. Some astronomers noticed that the brightness of Atlas didn't increase at a steady rate. Instead, it sometimes surged unexpectedly, almost like it was erupting. These bursts could be natural, caused by pockets of gas suddenly breaking free under the surface. Still, they added to the sense that Atlas wasn't just any comet. It was unpredictable, almost restless. To the wider scientific community, though, the message is clear. Atlas walks, talks, and shines like a comet. If you strip away the wild theories and alien headlines, the images show what our eyes have always expected to see: a glowing traveler, shedding gas and dust as it races past the sun. Strange in detail, yes, but familiar in form. The alien probe hypothesis. Up to this point, everything about 3I Atlas can be explained as a comet doing comet things. It glows, it vents gas, it grows a tail. But not everyone is convinced that's the whole story. Enter Professor Avi Loeb, a name that's become almost inseparable from the idea of alien probes hiding in plain sight. Loeb first made waves in 2017 when he suggested that Oumuamua, the first interstellar visitor ever detected, wasn't a rock at all, but a piece of alien technology. At the time, the claim split the scientific community. Some called it bold, others dismissed it as sensational. Years later, with Atlas now racing through the solar system, Loeb is back, and he's doubling down. In a paper co-authored with other researchers, he argues that Atlas's trajectory is too unusual to be coincidence. Not only is it on a backwards path compared to the planets, but its orbit lies neatly in the same flat plane where Earth, Venus, Mars, and Jupiter circle the Sun. To him, that looks more like careful targeting than random chance. By his team's calculations, the odds of an interstellar comet just happening to thread that needle are tiny, about 1 in 20,000. And then there's the timing. Atlas will swing behind the Sun at its closest approach, a moment when Earth-based telescopes are completely blinded. Loeb points out that this would be the perfect cover for a probe to deploy instruments, release smaller craft, or change its path, unseen. He also ties in the dark forest hypothesis, an idea from science fiction that suggests advanced civilizations may disguise themselves to avoid predators in the cosmos. In that light, a comet-like disguise isn't just clever, it's survival strategy. To Loeb, Atlas's behavior could be the calling card of intelligence trying to hide in plain sight. Of course, most astronomers reject this. They argue that Loeb is stretching statistics and ignoring simpler explanations. Just because a path is rare doesn't mean it's deliberate, and just because a comet brightens early doesn't mean it's running on engines. Extraordinary claims, they remind us, need extraordinary proof, and so far Atlas hasn't shown anything that can't be explained by natural processes. Still, Loeb's hypothesis hangs in the air, because the truth is, even if the odds are slim, the possibility is too big to ignore. And that's the tension at the heart of Atlas. Is it simply a giant comet, or the most cleverly disguised visitor humanity has ever seen? Science demands the ordinary first. For all the headlines about alien probes and hidden technology, the majority of scientists studying 3I Atlas agree on something simple. It's a comet. A very unusual comet, yes, but still a comet. Their reasoning is straightforward. Atlas is doing everything comets are supposed to do. It has a coma, a glowing cloud of dust and gas surrounding its solid heart. It has a tail that stretches out behind it, shaped by sunlight and solar winds. It brightens as it approaches the sun, just like countless comets in our solar system have done before. These are not signs of machines at work. They're the natural fingerprints of frozen material heating up and escaping into space. The odd chemistry, the overwhelming amount of carbon dioxide, the unexpected traces of nickel, doesn't necessarily prove anything artificial. To many astronomers, these details are exactly what makes Atlas so valuable. It's a piece of another star system, carrying chemical fingerprints that don't match the comets we know. By studying it, we get a rare window into how planets and ices formed billions of years ago in places we'll never be able to visit. In other words, Atlas might look strange only because it was born under conditions completely different from our own. As for its orbit and those impossibly close passes near Mars, Venus, and Jupiter, mainstream scientists argue that this isn't evidence of planning, just the lottery of cosmic geometry. Interstellar visitors can come in at any angle, and once in a while, one just happens to cut through the solar system in a way that looks suspicious. It's rare, yes, but not impossible. And in science, rare doesn't mean artificial. Astronomers also push back on the size debate. While Avi Loeb's team insists the lack of measurable acceleration means Atlas is far larger and heavier than early estimates. Others say the comet simply hasn't warmed up enough for strong jets of gas to show. The data is still coming in, and scientists caution against making bold claims before the full picture is clear. In the end, the consensus remains steady. 3I Atlas is a natural wanderer, not a machine in disguise. Its importance doesn't come from what it might be hiding, but from what it already is. A frozen relic from a different corner of the galaxy, carrying secrets that could rewrite what we know about how worlds form. Moments that will decide everything. The real answers about 3I Atlas won't come from debates or blog posts. They'll come from what we actually see over the next several months. Fortunately, this object has lined up a series of cosmic events that give us front-row seats to its behavior. The first test comes on October 3, 2025, when Atlas swings close to Mars. At about 18 million miles away, it won't light up the Martian sky like a fireball. But for orbiters circling the planet, it's prime time. NASA's Mars Reconnaissance Orbiter and Europe's Trace Gas Orbiter are expected to watch closely, along with China's Tianwen-1. These spacecraft will look for changes in Atlas's coma and tail, measuring exactly what gases it gives off. If it's a comet, we should see classic comet chemistry. If it's not, this is the moment something strange could show up. Just weeks later, Atlas disappears behind the sun in late October. For Earth-based telescopes, that's a blackout. Solar glare makes the object impossible to track. But spacecraft at other vantage points, including those stationed at Lagrange Point 1 between Earth and the Sun, will keep their eyes on it. Astronomers say this is when outbursts of gas should really kick in as the comet heats up. For Avi Loeb's team, this is also the perfect window for anything hidden to happen out of sight. When it comes back into view in December 2025, Earth gets its turn. Atlas will be about 170 million miles away, safe but close enough for James Webb and the Vera Rubin Observatory to probe it in detail. Webb will be able to measure its gases and dust with incredible precision, checking whether its chemistry changes as it warms. Rubin will take nightly snapshots, tracking its brightness and searching for any odd flickers or shifts that can't be explained by normal comet activity. Finally, in March 2026, Atlas makes a close pass by Jupiter, about 33 million miles from the giant planet's cloud tops. If NASA's Juno spacecraft can swing into position, it might even sample some of the dust streams directly, giving us the closest look yet at material from another star system. Each of these milestones is more than a date on the calendar. They're tests. Will Atlas continue to act like a comet with predictable jets, tails, and chemical signatures? Or will it pull something unexpected, a move that hints at intelligence behind the wheel? The answers aren't in theory. They're waiting in the sky. Why it matters either way. Whether 3I Atlas is a natural comet or something more, one thing is certain. Its arrival is already rewriting how we think about the universe. If the mainstream view holds true, and Atlas is simply a comet, then it's not ordinary by any stretch. Its unusual chemistry, rich in carbon dioxide and even laced with traces of nickel, makes it a time capsule from another star system. Studying it gives us a direct sample of materials formed billions of years ago, long before Earth existed. It's like holding a message in a bottle from another cosmic ocean, a glimpse into how planets and comets are born outside our solar neighborhood. For science, that's priceless. But if Avi Loeb's bold suggestion is right, if Atlas is something designed, a disguised probe quietly passing through, then the stakes are even higher. That would mean humanity has just witnessed its first confirmed contact with technology from another civilization. Not a radio signal, not a blurry UFO sighting, but a physical object, massive and deliberate, moving through our skies. The implications would be staggering. We'd no longer be alone, and we'd no longer be the most advanced beings in the story. Either way, Atlas matters. It challenges scientists to test their ideas, sharpen their instruments, and prepare for future interstellar visitors. Missions like ESA's Comet Interceptor are already in the works, designed to ambush the next object like this. The lesson is clear. The next time something like Atlas comes along, we won't just watch from a distance. We'll be ready to meet it up close. For now, Atlas races on, carrying secrets we may only partially uncover before it slips back into interstellar space. What it leaves behind is just as important. Terabytes of data, new questions about our place in the cosmos, and a reminder that the universe is never as predictable as we want it to be. So, whether Atlas turns out to be a comet from the stars or a probe from another mind, the story doesn't end here. It's only the beginning, because out there, beyond the reach of our telescopes, more interstellar travelers are on their way, and the next one could bring answers we're not ready for. Thanks for watching. If you enjoyed this deep dive, don't forget to hit that like button. Share it with someone who loves space mysteries, and subscribe for more stories that challenge what we think we know. See you in the next one.